Hey guys, today we're going to look at projectiles that are launched horizontally. So a projectile is an object that's being acted on only by gravity, and possibly air resistance. Due to gravity, the object follows a curved path. What do you notice about this little video to the right? You should automatically be noticing two things. The first thing is that the vector that is pointing to the right is staying the same length the entire time that cannonball is traveling. You should also notice that the vector that is pointing down changes as time goes on. Now, according to this little video, it changes by a rate of 10 meters per second. That's because they're rounding gravity from 9.8 meters per second squared to 10 meters per second squared. So I'm just going to make note down here that things that we're noticing is that the horizontal component of motion is constant. And we're noticing that the vertical motion is changing. The horizontal and vertical components of motion do not correlate at all. The horizontal motion of the 100 meters per second stays constant, but gravity is still pulling it down at negative 9.8 meters per second squared. So its vertical speed or vertical velocity is changing. So horizontal and vertical do not affect each other at all. They have one characteristic in common though, and that's the characteristic of time. Since this is a horizontally launched projectile, the amount of time it spends in the x direction is exactly the same as the amount of time that it spends in the y direction. So what this means, and this is what I want you to add to your notes, that the motion in the x direction does not affect the motion in the y direction. The vectors in the horizontal direction move at a constant velocity. This is because there are no forces acting on the object in that direction, and that's because we ignore air resistance just to make our life easier. Vectors in the vertical direction will accelerate. That's because gravity is acting on those objects in that direction only, so your velocity will be changing. Okay, so take a second and make sure you have this in your notes. This is essentially a motion map of the little video that you just saw. And we have two things happening. These distances are exactly the same as the cannonball moves because there is no acceleration. These distances increase as the cannonball moves because there is acceleration. Okay, so those are the two key things you need to keep in mind. When we do mathematical problems with this, that gives us two known variables automatically without even reading any of the problems. We know acceleration in the x direction is 0, and we know acceleration in the y direction is negative 9.8 meters per second squared. So this is how I'm going to have you set up all of your problems. We're going to use a t-chart because it separates out the x's and the y's because we know that they do not affect each other. So there are a few variables that we automatically know and a few that we're going to have to get from the problem. So the variables that we already know. xi we've used before, xf we've used before, ax is acceleration, that little x just means in the x direction, vix is the initial velocity in the x direction, vfx is the final velocity in the x direction. So of all these variables, we automatically, no matter what, know that ax is 0 meters per second squared, because we are ignoring air resistance and we're ignoring the things that are acting on that object other than the initial velocity that we pushed it off the edge of the cliff or the edge of the table with. Since that is 0, these two numbers have to be the same. So the problem will either give us enough information to calculate those two numbers, or it will be given to us. If we have vix, we automatically have vfx since ax is 0. Then we have xi, the initial position in the x direction, is always going to be 0 meters because that's going to be the edge of the cliff or the edge of the table that we're falling off of. So xf is the one number that we don't know. Now we're going to repeat everything else, but we're going to say y. yi, yf, ay, viy, and vfy. So some of these we can automatically fill in before we even read the problem. AY, the acceleration in the y direction, is always negative 9.8 meters per second squared. VIY, since in the y direction we're not physically throwing it downward, we are allowing it to just fall. This is going to be 0 meters per second. VFY, we're always going to be able to calculate, but these two, YI and YF, are always tricky because it depends upon your point of view. If we use the ground to 0 because ground level is our 0 point in most people's perspectives, we're actually going to make YF 0 meters. That means YI is some positive number. We don't quite know what it is yet, we just know it's going to be a positive value. Now, if your brain doesn't work that way, we can do the following also. We can make YI be 0 meters because that is where you are actually beginning, and YF is going to have a negative value. The issue with this green option is that you have to pay attention to your final answer. If it asks you how high is the cliff that you fell from, and you solve for a negative number, you should actually absolute value that number in order to get a positive height value. So instead, if you want to be correct every time without even having to think about it, make YF, or the ground level, your 0, and YI your unknown variable. Okay? Now there's one thing that's not written on these two slides, and that's the time. The time in the x direction is exactly the same as the time in the y direction, because as the object is falling, it travels in both directions for the same length of time. As it's being shot off the edge of the cliff or the table or whatever, the amount of time it travels this way is equal to the amount of time it travels this way. Now that is going to slightly change when we deal with projectiles launched at an angle. So on this slide, I'm going to go ahead and I'm going to star the things that we automatically know no matter what. So without even reading the problem, we know that AX is 0. You can plug that in every single time no matter what. We know AY is negative 9.8. You can plug that in every single time no matter what. And in horizontally launched projectiles, VIY is always 0. Now this will change in the next video, but for now, automatically 0, plug it in no matter what. And you know that if you solve for time, you have time in both directions. So, in the 4th grade, Johnny decided he could fly. So he put on his cape and climbed 8.25 meters up to the roof of his parents' house. He got a running start, traveling 2.4 meters per second when he ran off the edge of the roof. How long did he fly? Okay, so we're going to list our knowns and unknowns. And I know it's kind of silly that he just ran off the edge of the roof, but that works in this situation. Okay, so we have XI, XF, AX, VIX, VFX, and T. YI, YF, AY, VIY, VFY, and T. And I'm going to go back and add in those yellow starred items that I automatically know. I automatically know that AX is 0. I automatically know that AY is negative 9.8 meters per second squared, and I automatically know that VIY is 0. So now we're going to look back at the problem, and we're going to look at the other numbers that they gave us. He put on his cape and climbed 8.25 meters up to the roof of his parents' house. So if you use that 8.25 meters as his starting point, that is going to be YI. Because then he is falling to YF being 0. Okay? He had a running start traveling 2.4 meters per second when he ran off the edge of the roof. VIX and VFX are 2.4 meters per second. Now they're asking us to solve for two different things. The first thing is how long did he fly? The second thing is how far did he land from the house? Now looking at our T-chart, we need to decide what information can we use to answer the first question of how long did he fly? Now notice, in the X column, I have 1, 2, 3 unknowns. In the Y column, I have 2 unknowns. And if we think back to our kinematics equations, one of them we need, one of them we don't. So we're going to use the Y column to solve for the first question, because we don't need to know VFY in order to solve for time. We can use YF equals YI plus VIYT plus 1/2 AYT squared. So notice, this should be a Y. So YF equals YI plus VIYT plus 1/2 AYT squared. We took that XF equation and just changed all the little x's to little y's. So YF is 0. YI is 8.25. VIY is 0, so this whole number goes away. 1/2 negative 9.8 t squared, and t is what we don't know. So now we have to rearrange this equation. Subtract 8.25 from both sides, and we have negative 8.25 equals negative 4.9. I just combined these two numbers, t squared. Now we have to divide out, and t squared equals 1.68. We have to get rid of that squared, so we're going to square root both sides, and t equals 1.29 seconds. So Johnny was airborne for 1.29 seconds. I'm going to place that number here, and I'm going to place that number here because they are the same with horizontally launched projectiles. Now we're solving for XF, so we can use the same exact equation, but now in the X direction instead of the Y direction. I'm going to change colors to do that one. So we have XF equals XI plus VIXT plus 1/2 AXT squared. And XF is our unknown. XI we're going to make 0 because he's starting at the side of the house, so we're measuring out from the side of the house. Plus VIX is 2.4 times time, which is 1.29, and this last section completely gets crossed off because AX is 0, and anything times 0 is 0. So XF equals 0 plus 3.096. So XF is 3.096 meters away from the house. Okay, so there is an example problem of a horizontally launched projectile. We're going to be working with this multiple times, not only in practice problems and calculations, but also in a lab where we're going to launch a marble off a table and you're going to try to calculate where it's going to land. So I'll see you in class tomorrow so we can go ahead and practice this.